So we are now going to start discussing Lesson 8. The objective of Lesson 8, which is the top of your notes page, is to identify and use adjacent, vertical, complementary, supplementary, linear pairs of angles, and perpendicular lines, and construct perpendicular lines. Okay, so we've got a lot of vocabulary to cover in order to understand even what this objective is trying to express. So let's start by taking a look at the illustration we've got at the top of our notes page. And you can see we've got this illustration over here where we've got several lines that are intersecting. We've got a line called M, which is a vertical line, which is denoted by the script letter M over here. And that's the line going up and down, going through H. And then we've got a line that is at right angles to it, which is a horizontal line, which is AH or AD. And it's this line that I'm tracing with my pen. It goes all the way from the left to the right. And then there's yet another line, HC, that intersects H as well, and intersects the other two lines at H. And we're going to start by basically assuming that angle AHD, okay, is a straight angle, because we know that this is a line, AD is a line. So the measure of angle AHD as a straight angle, from what we learned in a previous lesson, is 180 degrees. And the measure of angle 2, which is our second question up here, go ahead and we look, and we've said that we're assuming that angle M and angle AD make right angles with each other. We can put a little right angle sign in there, and that would mean that the measure of angle 2 is 90 degrees. Let me make this a little bit more like a good angle sign. Good. Okay. Well, with that as a start, let's go ahead and define some of our first words. Perpendicular lines are two lines that intersect to form right angles. The symbol that we use to express perpendicular lines is this symbol. It looks like an upside down T. And if we go back up here and we look at which lines make right angles, well, we said that line M and line AD are making right angles with each other. So that means that line M and line AD are perpendicular. So we can express that in the following way. We can say M is perpendicular to line AD. So line M is perpendicular to line AD. Let's go ahead to our next word, adjacent angles. Adjacent angles are two angles that share a common vertex, share a common side, and do not overlap. Okay, they share a common side, so let's say that we want to try to draw a pair of adjacent angles, and let's let their common side be in green. So here we go. Here's a common side to two adjacent angles, and this would be one of the adjacent angles over here. Let's kind of show what that angle is. And then this would be another adjacent angle to the first one, which could be like this. So notice these two angles, do they share a common vertex? Yes, they do. Do they share a common side? Yes, each of these angles shares the green side. So therefore, these two are adjacent angles. Well, let's look up to our diagram and try to identify one or two sets of adjacent angles up here. Let's take a look. How about angles 1 and 6? Angle 1 and angle 6. Do they share a common side? Yes, they do. They both share this ray here coming from H. We don't have a letter here. I can make a letter up. Let's call it G. So we can say that angles 1 and angle 6 both share ray HG as a common side. They have a common vertex. They have a common side. Do angles 1 and 6 overlap? No, they do not. So therefore, we can say angle 1 and angle 6 are adjacent angles. Okay, good. Can we find another pair of adjacent angles up here? Well, actually, we have quite a few. Angle 1 and angle 2 both share ray HA. They don't overlap, and they both share the common vertex as well, the vertex H. So angle 1 and angle 2 are adjacent angles. In fact, angle 2 and angle 3 are adjacent. Angle 3 and angle 4 are also adjacent. And angle 4 and angle, well, we'll have to give a letter, we'll call this X down here. Angle 4 and angle DHX are also adjacent as well. You should spend a little bit of time thinking over those examples and convincing yourself that indeed all those pairs of angles are adjacent. They all have a common vertex, share a common side, and do not overlap. Okay, so we have a lot of pairs of adjacent angles. So let's move on to our next definition. Vertical angles. Okay, vertical angles are two angles whose sides form two pairs of opposite rays. Well, to make that a little bit clearer, let's go back up here and let's take a look at two angles whose sides form two pairs of opposite rays. Let's take a look at angles 1 and angle 4. Angle 1 and angle 4 are a pair of vertical angles. Well, angle 1, one of the sides of angle 1 is this ray, HG. And one of the sides of angle 4 is this ray, HC. Are those opposite rays? Yes, they're collinear. They're actually part of a line, part of line GH. So we've got one pair of opposite rays. Let's take a look at the other side of angle 1. The other side of angle 1 is ray HA. And the other side of angle 4 is ray HD. Are those a pair of opposite rays? Absolutely, because they also are collinear. They're all part of line AH. So here we've got two angles whose sides form two pairs of opposite rays. Notice that a slightly simpler way of thinking of vertical angles would be that basically they're angles that form when two lines intersect. So when line GH intersects with line AH, we get two vertical angles, angle 1 and angle 4. So we can say that angle 1 and angle 4 are a pair of vertical angles. So let's write that down over here. So we have angle 1 and angle 4 are vertical angles. But there's something more about vertical angles that makes them so important. Vertical angles always have equal measure. Okay, that's another way of saying that vertical angles are always congruent. So we can say, if we move back up here and we want to complete number 3, that angle 1 is congruent to angle 4. They are vertical angles, therefore they have the same measure, therefore they are congruent. Okay, good. You might be able to notice some other pairs of vertical angles here as well. How about angle 3 and angle 6? Angle 3 has ray HC as one of its sides. Angle 6 has ray HG as one of its sides. They're opposite rays. Angle 3 also has this part of the vertical line as one of its sides, and angle 6 has the other part of this vertical line, HX, as one of its sides too. So therefore, angle 3 and angle 6 are also vertical angles. And therefore, they are also congruent to each other. So we can say that angle 3 is congruent to angle 6. So let's write that in for number 4. Okay, good. Let's go on to our next definition. Linear pair. A linear pair is two adjacent angles whose non-common sides form opposite rays. Okay, their non-common sides form opposite rays. Well, the non-common sides of two adjacent angles is simply the larger angle that's the sum of the two smaller adjacent angles. Let's take a look at that. So that, for example, if we want to see a linear pair, we could look at angle AHC, AHC, and angle 4 right here. Because AHC and angle 4 are linear, are rather adjacent angles. They both share in common ray HC. And their non-common sides are ray HA and ray HD, which form opposite rays. Okay, let's take a look at that again. So AHC and angle 4, or CHD, have HC as a common side, and they have HA and HD as their non-common sides, and the non-common sides form opposite rays. Another way of looking at this is that if we add the two adjacent angles AHC plus CHD, we get a straight line, right? So the sum of this whole angle plus this angle is this plus this, which is basically 180 degrees. So we can say, because we know a straight line is 180 degrees, so we can say that the measure of angle AHC plus the measure of angle 4 is 180 degrees. And down here, we have the definition of linear pair. We just went over, and the sum of two angles that form a linear pair, therefore, must be 180 degrees. Okay, good. We have only two other short definitions left, that of supplementary angles and that of complementary angles. Supplementary angles are two angles whose sum is equal to 180. So if two angles are supplementary, then that means that the sum of their measures is 180 degrees. Well, we just saw two angles that are supplementary. That would be the ones we just looked at. Angle AHC and angle 4, because the measure of those two is 180 degrees. So we can say that angle AHC, whoops, let me kind of move this along a little bit. Sorry, kind of got lost there. Sorry. So I just wrote that the measure of angle AHC plus the measure of angle 4 is 180 degrees. That means that angle AHC and angle 4 are supplementary angles. Or we can just say for short, they are supplementary. Okay, and now let's look at our final definition. Complementary angles are two angles whose sum of their measure is 90 degrees. So let's go back up to our drawing here and let's see our illustration. Let's find two angles, the sum of whose measure is 90 degrees. Well, that would be a right angle. We know that M and AD are crossing at right angles, so that this is a right angle right here. But this right angle is the sum of angle 3 plus angle 4. So therefore, angle 3 and angle 4 are complementary angles. Let's go down here, and let's write then that angle 3 and angle 4 are complementary angles. And what we'll write up here is that the measure of angle 3 plus the measure of angle 4 equals 90. So we've completed most of the sheet. We've got ourselves at the top a very nice diagram that sort of summarizes most of the relationships that we've learned so far. We've got a couple of equalities that are important here and a couple of definitions here. Let me also just write in for linear pair. What I left out here is that angle AHC and angle 4 are a linear pair. Just to make sure we filled in everything that we should. Okay, good. In the next video, we're going to proceed to problems 7 and 8.